All right, it's that time of the week where I'm joined by Dr. V from OceanEd. And Dr. V, we're not writing today, right? We're seeing some ink here. What kind of experiment are we going to be doing?
We're going to do experiments with magnets.
Magnets?
So
okay.
before we go to the magnets, it's one of the 4 fundamental forces in nature.
I did not know that. Okay.
So others are the strong and weak interaction forces and gravity. And then the third one is electromagnetic forces.
Okay, there we go.
So this magnet actually we have is neodymium magnet. We're dealing with an interesting fluid. It's called ferrofluid.
Ferrofluid,
so it's basically iron filings, so basically a magnet responding material.
Inside the fluid.
So it's basically the composition is you have iron filings and a surfactant, which actually keeps the filings separate.
Interesting.
And then a base, which a oil or a solvent.
Keeps it suspended. Okay.
Suspended.
So what are we going to be doing with
colloidal
that?
solution. So I'm going to just have some of this ferrofluid.
And just put it right there in the plate. Okay. Now again, it's not reacting. It just looks like regular fluid right now.
Regular
just like
fluid.
a
And then, so what we're going to do is we're going to show the magnet at the bottom.
Oh, wow. Can you see that? That is amazing.
So what is happening here is that it's responding to the magnetic field now. And I have the magnet at the bottom.
Okay, so you're taking it away there. And now
so if I take it away, the spikes are bigger. And then if I bring it closer, the magnetic field is very strong, so you have more spikes there.
So you're really playing with the power of the magnet.
And I can make it float around.
Wow, look at it spread out like that.
So I'm going to just do one more interesting experiment here.
Okay.
So in this case, I have it in a
cup.
In a cup. So
oh,
it's
wow,
much
you
interesting
can really
to
see it there.
So it's actually like a flower coming out. And then if I'm pulling the magnet away, the spike is bigger.
Why does it get bigger when you go farther?
Because it's weaker, and if you have more, if you have stronger field close to it, the surface area that is exposed is higher. And also, I think if you join these magnets
both
and then
of them
make
together, make it even super strong.
Make a long magnet, and then I can see what is interesting. Maybe I need a little bit more.
A little more liquid there.
Sorry.
No, real quick. Let's show what we can do here.
If I see what is happening here is
both
that
sides.
the magnetic fields are stronger at the poles. So you have for a magnet, you have north and south poles. So you can see the magnetic field is very strong at the poles, and in between the interaction is lower.
Wow.
So you can see actually the flux, which is actually going from the north to the south.
The south pole.
Yes.
Very, very cool experiment. Again, we're going to have all this info on our web. And again, Dr. V, this is one of the experiments where you can really see the invisible power of magnetism.
And actually, you can make this ferrofluid at home. You can actually have iron filings in a suspension.
Cool. Well, thanks again. We're going to have all this info on another very cool experiment from Dr. V. And thanks for joining us here on Hawaii News Now. Wow.